Hello, everyone, and good day. My name is Sarah Grace. I want to welcome everyone to our informative webinar, Accelerating Sheet Metal Forming Using Dynaform. We have attendees joining us from around the world today, and we appreciate everyone taking the time to join us here. For over 38 years, ETA has been the leading provider in engineering software and solutions to clients and customers around the world. Today, we are bringing you another webinar in our ongoing series using the all-new Dynaform 6.1. Your webinar host today will be Jensen Chen, the VP of Global Sales and Marketing Dynaform. Jensen has over 20 years of experience in the CAE field using LS-Dyna and Dynaform, along with a widespread knowledge of modern formability, draw dyne development, and die system analysis. Jensen's co-host, Ming Zhang, is a senior project engineer and lead Dynaform support here at ETA. Ming has an extensive background in LS-Dyna and Dynaform sheet metal stamping, along with research in crash and safety for full vehicle and structure optimization. I would also like to introduce Mohsin Misra from our Dynaform support team, and our newest team member, Curtis Xiong from Dynaform Technical Sales and Support. The last few things before we get started today. After the presentation, there'll be a short survey poll. If everyone could fill it out, it would be greatly appreciated. If you have any questions during the presentation, please type them in the Q&A box in your control panel, and our Dynaform team member will reply to them as quickly as possible. We also have time for questions at the end of the webinar. Now, without further ado, I will turn it over to Jensen Chen.
Hello, can you hear me, Sarah?
Yes, I can, Jensen.
Okay, good morning, good afternoon, and good evening to everybody. I would like to thank you all for joining the Dynaform webinar. Today's title is Accelerating Sheet Metal Forming Simulations. My name is Jensen Chen, and I'm hosting this webinar along with my co-host, Ming Chang, and colleagues, Curtis and Mohsin. As we all know, Dynaform is a LS-Dyna-based die system simulation solution. Today, we will be presenting the application of formability simulations in Dynaform version 6.1. The application consists of two parts. Okay, before I get on to that, I like to share my screen. Okay. Right, the application consists of two parts. First part is multi-stage sheet metal forming simulation with data manager, and the second part is Springback compensations. The coronavirus disease has unprecedented impact in our daily life since early 2020. Today, the pandemic has infected about 112 million victims globally and claimed nearly 2.5 million deaths. In United States alone, we have nearly 28 million confirmed cases and almost 500,000 deaths. The damages caused by the pandemic is appalling. However, it also created opportunities for businesses, especially small and medium enterprises, to explore the implementation of pervasive simulation technology such as Dynaform to help shorten product development cycle of sheet metal stamping, improving product quality and profitability. Let's take a look at the outline of today's webinar. I will briefly cover ETA's corporate profile, Dynaform background and modules. Next, a quick overview of accelerating sheet metal forming simulation, part 1 and part 2 topics, which my colleagues Ming will perform the live demo. Okay. Then followed by that, we'll have the polling and Q&A sessions. ETA was established in 1983 by a group of engineers. We have been serving the automotive industry in the past 38 years as an advanced engineering service provider that supported over 40 plus vehicle programs. We currently have over 300 employees worldwide. We are also the software developer of ACP Op Design, VPG, Dynaform, and Presys. Dynaform is our flagship product for sheet metal stamping. It started as a small code developed for Ford model in 1983. The first version was released in 1996 with LS Dyna as the core engine, predicting metal stamping deformation characteristics. Over the past 3 decades, multiple versions were released with many new technologies for solving sheet metal stamping problems. We released version 6.1 a few weeks ago with key features such as Springback compensation and trimline development. The market spectrum of Dynaform is quite wide. We cover aerospace, automobile, motorcycle, electrical and electronics industries. Basically, any industry that involves sheet metal stamping is Dynaform's potential target. Dynaform consists of 6 distinctive modules. Blank size engineering, or BSE, is used to quickly perform blank material cost estimations, as well as improving blank material utilization rate. For mobility simulations, FS is aimed for deep drawing, progressive die, and line die stamping simulations. It helps to improve tool making cycle time by solving stamping defects prior to constructing the actual tools. We also have die evaluations, which is a very unique tool to help users to quickly evaluate draw die design, trimline, and also the sizes of scraps. For die structure, scrap flow, and sheet metal transfer issues, the die system analysis module can be employed to investigate various die system related problems, such as die structure fatigue, scrap blockage, and the interference during the sheet metal transfer processes. Dynaform also consists of blank and trimline development module, which is utilized to conduct near net shape simulation for prediction of blank outline and trimline using iterative optimization approach. Last, the tube bending and forming module is utilized to conduct CNC tube bending and tubular hydroforming simulations. All the features provided by Dynaform helps to troubleshoot stamping defects and improve product quality as well as stamping processes. Now let's take a quick look at today's part 1 and part 2. Okay, Ming will demonstrate the setup of multi-stage simulations. All right, so in here, he will show you how to quickly set up these processes and also utilize Data Manager to modify the processes. Okay, at the end, he will also present ETA report, which help us to quickly generate a report based on a predefined template. In part 2, we will have this very classic S-rail example to show you how to conduct Springback compensations using the automatic approach. At the end, we will run the polling and followed by the Q&A. Now, I would like to pass the torch to my colleague, Ming. Ming, over to you.
All right, thanks a lot, Jensen. First, let me start to sharing my screen. Okay, so in today's demo, we have 2 parts. For the part 1, we will do a multi-stage sheet forming with Data Manager. And for the part 2, we will do a Springback and compensation. Okay, first, I want to welcome everyone for joining us today. My name is Ming Zhang. I'm the senior engineer in ETA for more than 10 years. And also I'm the Dynaform support lead in North America. One more time, if you have any question during the demo, you can type them in the QA by using the QA function at the bottom from Zoom. Okay, first, I would like to start with our part 1. So in this case, we will be setting up 3-stage simulation, including forming and trimming, and then flanging. It's done by a side cam slider. Okay, so for those who are not very familiar with our new GUI, now on my screen, I'm showing the brand new Dynaform 6 GUI. So on the top, we do have the main menu buttons, like a project, BSE module, FS module, data manager, geometry manager, view, utility, result, ETA report, and help. Okay, so on my left hand side, here is the main window to do the like a tree structure setup. So we do have the operation. This is where we set up the motion, define the tools, and then the control tab. This is where we define all the control card. And then we do have the new added module, like a trimline and the blank outline development and Springback compensation, and then the job submit tab. Okay, on the right-hand side, we do have this main window for viewing the model, to check the mesh, to check the motion, to play the animation. Okay, so then I will just start to create this new project. I'll start with a new project, and for this one, I will just give a new name, multi-stage simulation. And then I'll just pick up the sheet forming and confirm. So the next step we need to do is to define our forming process. In 6.0, it's very, very easy to do it. So I will just click and drag these icons, which represent the stages. First, we need a forming, and then for the second one, we need to do a trimming. And then the third one will be running flanging. So also I'm able to change the position of these stage by move them up and down, or delete or add a new stage. And also in the new Dynaform 6, we assume all the tools, all the geometries we import to our database, they are in home position. This is very important because that will simplify the process to define the motion a lot compared to the old version. Because once we have the home position defined and then the stroke defined, so that means at the end of the simulation, all the tools will move to the home position. So if they are not in the home position, we do have an option here. So you can just toggle these tools are not at home position, and then later the software will allow you to move them into the home position. Okay, so I'll just click OK to confirm. So now we already have a new project created. So we will quickly do this setup one by one. So first we'll start with analysis. So under the analysis, we are able to define like a project name and then set up a simulation accuracy. We do have a fast and normal and accurate run or user defined. For this case, I will be using the normal. Okay. Also, we do support shell, T shell, and solid element. In this case, we'll just keep it shell. And also, we do support press coordinate system. Also, the tool offset type for this case, we'll be using the surface from the upper tool. So we will just use a contact offset, select the upper as our original geometry, and then the two contact offset value will be set up to 10% plus the thickness of the material. Okay, so the next step, we will go ahead and define the blank. And before we define the tool and blank, everything, we need to first import our geometry into the geometry manager. So I'll just go to geometry manager and then just import. In this folder, I do have all the information, all the geometries I need, like a bead lines, trim lines, and the surfaces for each stage, OB10, 20, and 30. I'll just open all of them. These are IGS or step file. Also in 6.0, we support directly importing the CATIA file and NX file from a CATIA part file. You don't have to convert these file format into IGS or step anymore. You can directly read them. And also once user import these geometry into the geometry manager, you can do some basic editing for lines and surfaces. These functions, they are not as powerful as full capability CAD software, but they will allow you to do some basic fixing, like delete some extra surfaces you don't need, or fill a hole, things like that. Okay, now on my screen, it is showing all the surfaces and the lines are showing on my screen under the geometry manager. So by default, if I exit this geometry manager, they are not showing on my screen because by default it is showing the mesh and the defined tools only. Okay, but if I want to turn them on, I can go to this corner, for hide and show the geometry. Okay, so next thing we need to go ahead and define this blank. We do support defined by outline, surface, element, or result file, means from a Dynain from your previous simulation result. In this case, we'll be using the outline. So we will not have symmetry for this part. We'll just go ahead and define this line and pick up from our geometry manager. So I'll just pick up this line here and confirm, exit. So now it is defined already. If I want to, turn on the mesh, I can go to the display the option and show the element edge. So in this case, I prefer to use a 16 millimeter to begin with. And also something is still showing red here for the blank, which is the material. So in this case, I will just go ahead and pick up one material from the material library here in Dynaform, and also change the thickness to 0.7 millimeter for this part. So by default, element edge is not showing. The reason is in Dynaform 6, we try to minimize all the mesh editing work. That means if you have a perfect staged geometry surfaces, most of the time you won't need to touch any mesh work. Okay, so now we have the blank defined. Let's move on to the next step, which will be our first operation. It is a forming stage. So before we start, let's click on this OP10 and make sure all the information here we want to use is correct. So in this case, we need to run a gravity load before this forming OP10 forming stage. So in the previous version, you had to define the gravity loading stage as a separate stage. But actually in 6.0, you don't need to do that anymore. You can just finish your OP10 and make a one click, check this gravity load, then you're all set. Okay, also we also support this pre-bending function. It will allow you to do pre-bending along the certain axle. It could be X or Y, and also they do support different mode here. Also, this is where we define the main motion, the main stroke here. We are giving an 800 millimeter, so this good enough. Okay. So once we make sure these are all correct, let's go ahead and define the tools. To define the tools, it becomes very, very simple compared to the old version. We can just go ahead and click on define and hide the geometry. I don't need here. Now I'm showing the OP10 surface only. So I can just select by layer. So all the surfaces are selected. So once I click on include, that means all the surfaces which are highlighted now, they will be defined as a die on the top. Okay. So similarly, we will go ahead and define punch and binder. So I will go ahead and define the punch from the top view. I will be using multi-line to select all the surfaces inside my lines. Okay. All right. So this center area will be my punch. So the next step, I will go ahead and define the binder. I will use a similar method, but exclude the area where should be punch, and then the outside area will be my binder. Okay. So once I finish these lines, I will just confirm and then include. So now if I exit this window, now from my screen, you can see the tools position has been defined. But then you might notice why this binder is this high, because we don't, we are wasting some calculation time. Then there's one very useful function here called the fitting and reposition. Once I click on it, so the binder will be automatically repositioned based on the lower tool position and the binder position. Also, if you know the stroke, you can always manually input it here. Okay, then you might notice there's still a big gap between the blank and the upper tool. There's one option before you submit the job. It's called the reduce stroke press stroke. And then if that one is checked, if you preview, they will reposition this upper tool to save more time. Okay. So for defining this single action simulation for the upper tool, which is die, it is showing fixed. That means this is the fixed to the run. Means it will move with the run with a certain velocity and travel 800 millimeter to the fully closed position. And for the lower tool, the punch will be stationary, so it will be fixed to the bolster. For the binder, since it's an unfixed tool, it will be controlled by 3 ways. We can do it either by force, spring, or velocity. In this case, we'll be using the velocity. Means once the upper tool clamp, fully closed with the binder, they will move together all the way down to close with punch to form this part. Okay, so the next thing we need to define for OP10 is a draw bead. So in this case, we do have a double bead in some area. So we need to run this at a multiple draw beads. Then I'll go ahead and select the bead geometry, bead lines here in the geometry manager and just confirm, click OK to confirm. Now as you can see on my screen, let me take the top view. On my screen, I do have 3 beads generated. Bead 1, which is the fully closed one, and then the bead 2 and 3. Okay, so for bead 1, actually, I plan to use a variable bead. In 6.0, it's very easy to define this. I can just go ahead and click on Add and pick up the area where I want to, do a variable bead, and then just keep adding this. Okay, and then maybe keep added here. Okay, so once I finish that, then you will see 5 segments for this bead. They have been generated. Now I can just go ahead and assign this locking force from 0 to 100%. 100% means fully locked. So for segment 1, I will be using 15%. So for number 2, I will be using 45. For number 3, I will be using 15. For number 4, I will be using 30. And then number 5, I'll be using 30%. And then similarly for bead number 2 and 3, I'll be using just 10%. Okay. Okay, so now I'm all set with this OP10. I can check the animation now, or I can do it later. I will show you how to do it later once I finish everything. So next step, we will go ahead and define this trimming stage. So in this case, we need to run this trimming stage in a different position. So we will apply 1600 millimeter in X direction, and also a 2-degree tipping for this blank. So I'll just go ahead and apply these. Okay, and then for define the trimming stage is simple, very simple and easy. I'll just pick up the trim line from the geometry manager. Here it is. So now since this is a 3D trim line, so I prefer to use a laser cut. That means a 3D cut instead of 2D. Okay, that's it about the OP20. Now let's move on to the OP30, which will be flanging by a side cam slider. So in this stage, we also need to run another 1600 millimeter in X direction, and also another 2 degree in Y, negative 10 degree in X, tipping for the blank. And also similarly for 2, we need to run the same transformation in X direction. And then once we finish that, let's look at our tools. For the upper tool, we don't need this still. I can just delete it. We need the pad, hold the blank from the top, close with the post. And then also we need to add the cam. I'll just right click and add the cam here. So for defining all these tools, very, very simple and easy. And just go define and pick up the tool from the geometry manager. Okay, so this is the pad. And then the next thing is a post, which will be our lower die here. Okay. So the next thing it will be our cam. I'll just go ahead and pick up the layer for cam slider. And now we have all the tools defined. But you may notice, okay, this cam is not in the right position because we need to go ahead define this working direction for the cam. In this case, we'll be running an angle. I'll be using negative 110 and just confirm that. So this stroke for the cam is pretty large. I'll just using 100 millimeter. Okay. Something is still showing red. It's a cam process. That means we can define how we want the cam to move. We can define it after the main motion. It means so after the pad hold the blank from top, then this cam will start to move. Okay, after we finish all of them, we can go ahead and check this animation by clicking the animation button. Let me change your view to the ISO view. Okay. Okay, this animation for the OP10 looks all right. Now let's check the OP30. Okay, first the pad will hold the blank from top, then the cam will move in to form this flange. Okay, everything looks fine. So let's move on to the next step. We will go ahead and look at this control tab. This is where we define all the control parameters for running as Dyna. In the old version, these are control parameters are everywhere. Sometimes a lot of users are confusing, by finding where are these parameters, how we can find them. But now in 6.0, we do put them all in one tab. Like for blank, you can go here and change the blank parameters, or even editing the blank, editing the mesh, set up the refinement. For the forming stage, well, you can change the element formula, change the adaptive mesh level, refining mesh parameters, define the draw bead box, and even define the timestamp and the contact for each tools. Also, you are able to define the friction coefficient between the tool and blank. Similarly, for trimming and flanging, you can change everything control card here. In this case, I prefer to use this normal, so I'll just leave it as a default. Then I can go to the job tab and submit this job. In the job tab, I can change the solver version or solver single or double position, number of CPU, memory, and start with which stage. Also, I'm able in 6.1, I'm able to use the defined keywords to refine the keyword, more customize the keyword tuning for the experienced user. Okay, so if I submit the run, it will start running the this simulation. For saving time, I already have this result run. So now I can just by clicking on this result to switch to the post-process window. So in the previous version, pre and post processor, they are separated. They are different software, but in the Dynaform 6, they are unified in one GUI. Once you have the simulation result, just make a one click on this result button, then you're able to do the post process. Okay, now as you can see, I can play the animation. I will not spend too much time on this one, but I will just show you some main items I want to check, like the FLD. I can set up the tools as a transparent or just show the blank only, hide all the tools. Then just I can play animation, and I can pause somewhere, do the measurement. For example, let me switch to scening, and then just using this list value to measure this area where I want to do the measurement. Also, once I'm done, I can easily move this mark or balloon for a better angle to take a screenshot, put it on the report. Then talk about the report. We do have a new tool, very powerful tool. It's called Eta Report here. So it is this button. Once I click on this button, it will jump to open PowerPoint. This is based on Microsoft PowerPoint or Excel. Now we are looking at one template here. So in this one, if you want to update one page, since this Eta report is linked to our simulation result. If you look at this corner, I can just link this report to the index file from the simulation result, and then go to one of the slide. For example, if I want to update this general information, I can go here and just click on the slide and then click on the update. And then the Eta Post will start the program, and then start to collecting all the information and take the pictures I need to fill this slide. Similarly, if I want to check for example, there's a sickness page, I can go here and do that also. If I click on this update all the slides in this presentation will be updated. That will take a very long time. I will not do it now. So now on my screen, as you can see, this slide has been updated. If I want, I can edit object, like changing the legend, changing the change the view, change the colors for this slide, and also even I can using a different angle. For example, I don't like this angle. I want to apply 30° along Z axle, so I can do that. Okay. It will just take a few seconds. Okay, now this angle has been applied. So also there's one option called the switch to Eta Post. Okay, so once I click on this slide and click on switch to Eta Post, so what the software do is that they will open it in the Eta Post, and then you can do more operation like a zoom in and out, changing to a different angle. For example, for this part, I want to look at this area. I like to zoom in and look at this local area. I can switch to my report and then say I want to plot from Eta Post, then they will update this slide based on this. Okay, so once I'm done with this operation, I can go to the last one, create a new slide. As you can see on my top, I do have file 1 and 2. If I also link another result from my from my different iterations, I can also add this plot by comparing two simulation or two iterations. Okay, so that's basically about the Eta report that will show. Let me just close this one, and let's say I'm not satisfied with this simulation result here. So in the previous version, if you are not satisfied, and then you may need to change some parameter or change your geometry in your simulation, you have to save this project file as a new file, then rerun it by changing the parameter in another folder. But actually in 6.0, we do have a very, very powerful tool called the data manager here. So for example, let me do it here. In this case, this one is where I set up the original simulation. What if I want to, for example, by using a different trim line here, rerun this simulation? So in 6.0, very easy. I can click on drag this trimming stage and then just put it somewhere between the forming and trimming and release it. Now I'm creating a new branch for the simulation. And then I can also copy this flanging. I want to keep the same. I can just copy them. So now what I need to do is I can switch to this new branch as my current simulation and then modify this trim line by going to the trim stage and then replace this trim line with the new trim line. By doing this, I'm keeping the result from the first stage OP10 forming, without rerun it, but rerun the trimming stage with a new trim line and then rerun the flanging stage. Okay, so another example, let me show this one. So in this case, I just copied the forming, trimming, and flanging. In this new branch here, actually I did change the draw bead locking force. I changed the double bead area from 10% to 30% in this case. And then I want to compare the result between the two. I'll show you another feature. It's called the multi-window. So for the first one, if we use the current one and switch to the result, then let me just switch, go to certain stage and then show the FLD. Hide all the tools. Okay, this is what we want to compare between the two iterations. Now let's move to the second one. In this one, I want to use the new branch. Okay, and also let's do the same process to switch to the post. And then go to the same stage and hide the tools, show the FLD. Okay, let me sync the view. Once I sync the view, if I rotate it, you will see, they will use the same view. On my right-hand side, you can see the different iterations here. Once I, increase the locking force here, somewhere the crack happened. And similarly, if I check the sealing, it will just plot the sealing difference for you. This is a very, very powerful and useful tool. All right, so I think that is everything about the part one. Now let's move to the part two, which will be the Springback and the compensation. So I will be using this example for the part two, which is a very simple single stage simulation forming. As you can see on my tree structure, we do have the forming stage OP10. Then we do have the Springback stage for OP15. We are running a constrained Springback. Also, Dynaform, you can run the free Springback here. But in this case, we are running this constrained Springback. Okay, I'm not going to talk about too much about the setup this simulation. I'll just talk about the Springback and the compensation part. Okay, once we have the Springback stage here in the simulation, you will see this tab SCP Springback compensation tab become available. Then users are able to set up auto or manual Springback compensation. Okay, so under this tab, we can set up the master tool. Like now, currently, I'm selecting this die as my master tool. All the other tools like a punch and binder, they will consider as a slave tool automatically. And also, we are able to set up local Springback compensation, not running for the all zone. And then we do have the parameters here. We support different methods. They are explained very well here in detail. And also smooth level scaling factors and undercut to avoid undercut option. And also number of iteration, we're using default 3 iterations. Okay, once we are done with these iterations, you can, if you are not satisfied with a certain iteration, you can manually go back and rerun that iteration only. Okay, so very simple. For submit this Springback compensation job, just make sure you toggle this auto SCP, then the Dynaform will start to run this Springback compensation. Okay, since I have run this already, so I will just show you some result by running this Springback compensation. Now, as you can see, I do have 3 iterations finished. The number 3 do have a 0.1392 millimeter deviation for average. So I think this one is the best one so far. Okay, so then I can just turn on the compensated geometry. If I want to take a section cut here, I can easily check the difference between the original geometry and the compensated geometry. Okay, and then later if I want to let me activate this one, remove the section cut. If I want to export the compensated geometry, it's very simple. I can go here and just click on export. Then using a STL format, I can export this geometry. Then you can send it to the CAD drafter or die phase engineer. They will use this new compensated geometry as a reference to modify the die phase. Also, we can plot the deviation here in this window. Then make a measurement, where we want to measure the deviation value. Okay. Also, we can show the histogram here for the model. Okay. Also, we are able to export the boundary line. Also add it to Geometry Manager. So actually, running this as Springback compensation in new version, it's very simple. Okay. All right. I think that will be the end of my demo. Next, we will do a pooling. I think let me see how to launch it. Give me 1 sec. Yes, now I just start the pooling. There are several questions. Make sure you scroll down. After you finish the first one, you scroll down to the bottom before you submit the pooling result. We really appreciate your feedback. It will help us a lot for improving our software. Okay, I will give another 1 minute, maybe 1 or 2 minutes for everyone to finish this pooling, and then we will start the Q&A. Always, if you have question, you can type it in the QA box, and also if you want to ask by audio, you can raise your hand, and then we can unmute you. You can communicate with us lively. Okay. Okay, Cici, there are some questions in the QA. Do you want to
Yes,
answer them?
we do receive quite a number of
Okay.
questions from our
Yes.
audience.
Yes.
So and Mosing has been busy replying them, but there's still
Yeah.
quite a number of them, So
Yeah, if you see
some we
of
do
them
have to
you prefer to
demo it.
show it, yeah, demo it in the software, let me know.
Yes, actually, one of the questions, yeah, we do have to demonstrate the features. Okay, so let's wait till the end of the polling, then we'll continue with the Q&A, and
Okay,
then you
I'll
can
just,
demonstrate how to
yeah.
conduct certain operations.
Okay, I'll just end the polling now.
Ming,
Yes.
Ming, could you also show how to select the surfaces using tangent option? It was one of the questions.
Yes.
Yes,
I'll show
correct.
that.
Yeah.
Okay.
Okay. So now let me switch to pre and quickly show that feature. So actually when we're defining the tools here, for example, for this die, oops, okay. So if I, let me exclude all of them.
We can unmute the audience, right, Ming?
Yes, we can.
Okay, so for those who would like to ask questions, you can, I think, raise your hand, and
Yes.
then we can unmute you. Then you can ask the questions. Okay.
Yeah. When I, for answering that question, for selecting surfaces, we are in the defining window now, in the geometry manager. There's one option called the tangent surfaces. If I just click on one of the surface here, it will search all the surfaces, which have a tangent relationship to this one. It will keep searching since on these surfaces, everything is smoothly connected. So it will select all the surfaces here. Also, we will add the new another feature called spreading to change the degree when we defining the tools. That will be added later. Okay. All right. Anything else?
Yeah, we have another questions from our partner asking about the best fit. Okay, so is it possible to do a best fit of the geometries before plotting the residual deviation in SCP?
Oh, yes. Actually, let me. Okay. There's one option called the best fit. So before we start to running the Springback compensation, we are able to fit the Springback the result after Springback result with our original geometry. It will provide you, the better result for running this compensation.
Okay, so we have also another questions. I'm not sure if Mosing's answering it. So the major difference between 6.1
Yes,
and
I
6.
answered that.
Okay.
Yeah.
All right. Yeah.
Ming, just a reminder, could you show how to do the tangent surface?
Okay, the major difference, I think Mosing already answered part of that. It's with the annealing process. Okay, Ming can show that annealing process in process definitions. Okay, so we add that. Yeah, that's with the annealing process. And also another good feature that's implemented in 6.1.1 is the automatic adjustment of the tool or the pin for guiding the blank in streamline development. Okay, sometimes you have a pin or a guide pin that's positioning your or locating your blank locations. That pin or guide will be automatically updated after we optimize your blank outline. Okay, so it wasn't supported in the older versions or 6.0. So this is a very new features that's being implemented in 6.1.1. Okay, so we still have a number of questions. So let's go through it. We have a question asking about the laser cut. Why do you select laser cut options in trimming operations? I think you can demonstrate the trim operations. So in this setup here, we have a 3D trim lines. In the actual stamping process, this will be separated into several steps. But we are just saving the time for running the simulations. So we cannot use a 3D trim lines instead of running trimming at different stages. All right. So if we are going to use a 3D trim line, we cannot perform a direct trim because it's in 3D geometry. So that's why we have to set up laser cut options that will allow us to trim according to the normal of the elements. All right. Okay. So also have a question here, Ming, asking if you can show us how to use local zone with Springback. Springback compensation, I suppose that's yeah, localized Springback compensations. So like you need to define local region before running a Springback compensations.
Yeah, to the Springback. So when I in here, I can use a local instead of all, and then define the regions. It will select by curves. If I do have a curve like this, then it will only compensate the region between the two curves, which will be this radii area. Okay, instead of using the all for the all the model, all zones here in the model.
Okay.
Okay.
Thanks, Ming.
Yep.
Here's the next questions for you. Can you create a report template to show different frames?
Yes,
so
of course.
I suppose, yeah, we can. This is like doing the breakdown of each frame. So we can individually add the slides, in PowerPoint or Excel, and then add the frame individually, locally, right? So we do have options that allow us to select, all right, the steps, final step or which step. All right, so you can select the frame, right? So I guess you answer that, right?
Yes.
Gauge is T, why needs 10% tolerance? All right, so this is just a recommendation. We've been doing this for a long time, but in some cases, user or they do modify the tolerance, because of the simulations models. So some tolerance will give you a good result compared to the other type of tolerance, but the rule of thumb is we usually have a 10% tolerance. But in my experience, we sometimes use T, just directly using T, without using the tolerance. In this case, we have that because we are using a contact offset, right, Ming? So we're gonna have that a tolerance. But if we're using the physical tool, sometimes we don't even have the tolerance. Okay. Oh, here's another question here. Is the free E3D viewer still available? The answer is yes. We still have that. We just don't talk about that. All right. Now, Ming, can you show the line to geometry bit? Maybe just quickly, or one draw bit instead of all, because it might take time to generate. We have a few more minutes, and then there's still quite a number of questions we have to answer.
Yeah, we do support this geometry bead. So just by one click, we can convert the line bead to geometry bead. It will modify the mesh here on the model.
Okay.
In this case, it will not apply because it's somewhere is very close to this radii. We set up a gauge, to make it safe
Okay.
to modify the mesh. Yeah, maybe I can just quickly show it on this one. So for the draw bead, if I add a bead and define it here.
Yeah, just a straight line. Yeah.
And then if I prefer to use a 50% here from our library, it will use this geometry to modify the bead, to modify the upper and lower tool.
Yeah, so
now,
you
as you
can
can
see
see,
how quickly we can generate
yes,
the physical draw bead, for the upper die and the binder. It's
yes,
almost instantly we can create that. All right. Okay. So
okay.
we have another question about Tata Steel FLD. I think we offer that Tata Steel FLD. That's in post processing. Okay,
Yes,
right here we also have it. Yeah.
Tata Steel.
So we have the Tata Steel FLD. So it's much more accurate if we are dealing with an advanced or ultra high strength steel. Okay. Another questions, if we check in undercut avoidance in the springback compensation, how will we understand that if my die is going undercut during compensations? Okay, so this is in the SCP. So if this option is checked, that means we have a program that to calculate, if after compensations, the wall will be, under 90 degree or not. If it's under 90 degree, then we will not compensate that wall. So, right, it's the internal program that we will avoid that, right? I think we have a couple more questions, which is about the right time. Can we use YSTS directly? Currently, no, we don't have that conversion yet because we also need more information other than just TS and YS for the material definitions. All right, we will need the N value and the R value. So usually our material suppliers have to provide this value for us. Then we can generate the stress strain curve. Okay. All right, we have a couple more minutes left, and I think it's enough time for us to answer our last questions. Other than FLD, what are the options to inspect Class A surfaces? So it's in the post-processing, right? Maybe you can demonstrate that, Ming.
Yes.
Options that we have. Yeah.
Yeah, actually, we other than the this option, we do have first we do have this skid mark check. So that will trace the skid mark in make sure it doesn't slide out of the radius area. And also we do support check the main strain. And then we also have this is zebra light, for checking the surface quality. I think the last one for Class A surface, it will be this stoning check. So it will check the default, for example, check the default, the defect near the pocket area, like the handle on the door panel or tailgate. We'll be using this as stoning function. Okay.
Okay. Yeah. I think that's all the questions that we have here. So if you guys have more questions, you are welcome to address this question and send it to us to support@eta.com or info@eta.com. One of our guys will be able to assist you. So I think that's all from my side here, and over to you, Ming.
Okay. Yeah, that's all from my side also. Sarah.
Excuse me,
All
Sushi,
right.
there is one more question, last question, I think.
Yeah. Yes.
Oh, wait.
Any future GPU capability?
That we have not explored these options yet. Basically we are relying on LS Dyna. It is an explicit code, so it does not work very well with GPU. That's why we are unable to implement these GPU capabilities. But we might be developing, for example, BSC, we might be able to explore that. We have our own solver, the M-step solver, and that's considered like implicit. So it's possible that we can consider GPUs, but not in the short term. All right. Okay, that's all.
All right. Thank you, Jensen. Thank you, Ming. Hello again, everyone. We hope you found this presentation informative. We'll be uploading the recording of this webinar to our website and YouTube pages soon. And please keep a watch out next month for our upcoming webinar where we will be covering the all new features of Dynaform 6.1. If you have any questions or would like more information, do not hesitate to contact our Dynaform team, and they will be able to help you with everything you may need. Once again, thank you for joining us today. Have a great day and stay safe.
Thank you, guys. Goodbye.
Thank you, guys. Bye-bye.